We are out on a farm today in Sangamon County to check out the installation of a grade stabilization structure using a material that we've yet to use in Illinois, but may be seeing more of in the future. The material is a tied concrete block mat that will be used to form a chute structure. This type of structure can be used to sometimes fix large gullies caused by erosion. This practice is being installed to replace an older concrete overfall or weir structure that was intended to control the flow of stormwater from the crop field, allowing the water to drop about 8 feet into the adjacent ditch without taking any soil with it. You can see here that the weir structure has failed. The ditch has now bypassed the structure and is working its way up into the grassed waterway coming from the field. This practice failed because it was severely undersized for the amount of stormwater runoff it experiences. Runoff from more than 800 acres flows to this point. As runoff from storm events approached this location, the flow would become very deep as it tried to pass through the narrow structure, sometimes higher than the concrete wing walls. Once flows begin overtopping those wing walls, the soil around the wing walls begins to erode. Eventually, the ditch cut its way around the structure. After repairing the erosion a number of times over the years, the landowner decided to consult with NRCS to address the gully erosion. With the failure of the overfall structure, we needed a way to safely convey water from the grass waterway in the crop field to the downstream channel, and a chute-style structure was selected. Chute structures can be constructed using a variety of materials including rock, cinder block, articulated block, and tied concrete block mats. All of these materials provide protection from high water velocities to eliminate erosion, and all of them have their advantages and disadvantages. Some of the factors taken into consideration when choosing the best method to address a resource concern are effectiveness, overall cost, material availability, labor and equipment requirements, and aesthetic impacts. The tied concrete block mat did not have a significant difference in cost, but does require much less labor to install than the rock or block alternatives. A rock riprap chute would also require a larger footprint area than the other materials to address the same erosion. And even though the rock is a natural material, it could have a greater visual impact because of the extent required. Maintaining or enhancing the landscape is an important aspect of the NRCS mission. In high visibility areas or significant landscapes, the visual impact of a practice should be taken into account. In different situations, different practices or materials may be more suitable. In this case, tied concrete block mat was a selected alternative with the best balance of cost, labor, and aesthetics. When this particular type of mat is manufactured, they cast the concrete blocks embedding the grid into the block. The grid ties the blocks together, allowing the mat to flex and move without the blocks separating from each other. The geotextile adheres to the bottom of the blocks. The geotextile backing acts as the primary barrier protecting the soil from high velocity flow. The blocks hold the geotextile in place. They also help slow the water down. On its face, a chute may seem like a pretty straightforward structure. It is, however, made up of a number of different components: an inlet apron, a main chute, an outlet apron, and the side slopes. Water flows from the waterway and enters the structure across the inlet apron. The upstream edge of the inlet apron will be keyed into the soil using a 24-inch anchor trench. This will ensure that the water goes down the chute and not under it. Water will flow from the grass waterways into and down the chute. This is essentially a controlled overfall where fast-moving, concentrated storm flow would otherwise erode bare, unprotected soil. The tied concrete block mat also protects the side slopes to ensure that the entire flow is carried on the mat surface and does not come into direct contact with the soil. Finally, the water will exit the chute structure, crossing a 13-foot outlet apron into the ditch. This outlet apron acts as a splash pad to dissipate the energy of the high-velocity water exiting the chute. The outlet apron, like the inlet apron, is also keyed into the existing ground using a 24-inch trench. This downstream key adds some protection to hold the structure in place in case the downstream ditch becomes lower than expected for any reason. Overall, the tied concrete block mat will cover an area 80 foot in width and 55 foot long in the direction of flow. Those dimensions include the inlet and the outlet apron as well as the side slopes. This chute will serve as the principal spillway and is designed to carry the 25-year storm event. In this area, that's equivalent to the runoff from a 5-inch rain within a 24-hour period. This project also took about 1 week to build. A large excavator was used to unload the rolls from a flatbed trailer at the road and bring them back to the project area. The contractor started out by removing the concrete weir structure and vegetation in the area. The concrete block mat requires a firm subgrade, free of any debris or vegetation, or anything else that would prevent good contact between the mat and the subgrade. With the site cleared, the dozer can begin rough grading. Here he is going across perpendicular to the slope of the chute. On this project, there was more excavation than earthfill, so extra material was hauled out of the construction area and spread in a designated location where excess soil could be placed and graded so it would not negatively impact the site. Likewise, any debris or limbs discovered while working the area were hauled off to a debris pile. With the rough grading completed, the contractor can now start working on the inlet apron and trench at the top of the chute slope and the outlet apron and trench at the bottom. The contractor excavated the area of the outlet apron, being sure to set the layout and depth to the location and elevation specified in the design. Meanwhile, a trench was dug for the inlet apron at the top of the slope. Survey shots were taken to make sure everything was laid out according to the design. When they did this, they discovered the inlet trench wasn't exactly perpendicular to the slope. So, they decided the trench needed to be backfilled and re-excavated, making sure it was laid out as in the design and perpendicular to the slope. Starting out so everything lines up as laid out makes installing each roll parallel to one another much easier. The engineer laid out flags for the inlet apron and trench, and the new trench was then excavated. At the same time, work continued on the outlet apron. They excavated the trench, checking to make sure they had enough depth. You can see the trench is filling with water. A common hurdle when excavating within a channel is managing tailwater during construction. Water can accumulate within the excavated area, either by surface water or base flow. In this case, a sump or low area for water to collect can be dug out, and a pump can be used to pump out the water. Even with the pump in place, water continued to be a challenge. With the inlet and the outlet apron elevations established, the dozer could now grade the chute slope before moving on to the side slopes. The engineer worked closely with the contractor throughout the process of installing the tied concrete block mat rolls. Here you see the engineer checking elevations and the layout of the outlet apron before the contractor moves forward. Continuous elevation and grade checks, along with fluid communication with the contractors, was the key to having a smooth installation process. The tied concrete block mat, as you can imagine, is heavy, about 10 pounds per square foot. One roll of this structure would weigh over 3 tons. Heavy-duty lifting straps make it possible to pick up the rolls from above. Lift straps come ready for use with each roll and eliminate the need to pick up the rolls from below, which would risk damage to the integrity of the mats. As each roll was moved into position, the excavator made sure the roll was placed in the right direction so it would unroll down the slope and it would follow the desired line as they unrolled it. For this project, the rolls were unrolled from the top to the bottom of the slope. In some cases, the rolls are unrolled across the slope instead. The first roll on this project was placed at the far north side of the chute. Then they worked their way across the chute. We're going to take a minute and speed this up to give you an overview of all the mats going in. Then we will come back and take a closer look at the installation of each roll. That went pretty fast, but it actually took a day to install all of those rolls. The rolls are made so they overlap the geotextile of the adjacent mats. Each roll has a 12-inch extension of both geogrid and geotextile that extends beyond the blocks on one side. This extension makes it possible to overlap the second roll and each subsequent roll, ensuring there are no gaps in geotextile or geogrid that is protecting the subsoil. The mats look like they could be easily smoothed, but that is not the case. They are heavy and the excavator is needed to smooth out any kinks. The placement of each roll also needs to allow for the mat to unroll into the outlet trench at the bottom, at least 24 inches. The mat didn't always roll down the slope exactly in the position the contractor wanted. Here the excavator is nudging the roll over so it overlaps the 12-inch geotextile geogrid extension. The last roll to go in went in on the southern side slope. The side slopes can be more challenging than the flat portions of the chute to unroll the mat. Before they laid the final roll on the side slopes, they did some fine-tuning on the slope. Once they placed the roll, they discovered the roll was not close enough to the trench. The roll had to be nudged closer to make sure that 2 foot of the mat laid in the trench. When the mat is laid on the side slopes, it will eventually creep down slope as it is unrolled. On this last roll, the excavator and mini excavator worked together to unroll the mat down the side slope. Working together, the two excavators were able to better control how the mat unrolls and make adjustments as needed. The last roll also does not have the 12-inch extension flap that the others did, since there won't be another roll being placed adjacent to it. With the mats installed and laid into the trenches, both the inlet and the outlet apron trenches were backfilled and compacted to hold the mats in place. The proper installation of these trench anchors is not only important for holding the mats in place, they also prevent water from getting underneath the mats at the inlet apron and protect the outlet apron from downcutting of the downstream channel. With the mats in place, crews come back and install stainless steel zip ties every foot along the seams to connect the rolls together. The zip ties are installed perpendicular to the flow of water. Over 400 zip ties were used installing this project, effectively turning the 8 rolls that were installed into one continuous mat. The chute structure will act as the principal spillway and will handle the majority of all flows coming from this drainage area throughout its lifespan. If you remember, this chute was designed to handle about a 5-inch rain over a 24-hour period. There will be times when this area receives more than a 5-inch rainfall event, and we do not want the runoff to damage the structure, so we designed a low point or overflow area off to the side to handle those infrequent but high flows. This low area works to prevent the berms from being overtopped by water during large storm events, which could easily cause erosion and eventual structure failure. Here they are constructing that low point to the south of the structure in undisturbed soil. If and when high flows happen, there may be some minor erosion in that low point, but it will be much easier and less expensive to repair than replacing the tied concrete block mats. The areas disturbed by the construction need to be revegetated to hold soil in place. The construction site received a lot of vehicle traffic during installation of the structure. Before the contractor could put seed, fertilizer, and straw mulch, they prepared the seedbed, eliminating compaction and clods and loosening the soil surface in order to get good seed-soil contact and ensure successful germination. For this site, they planted a commonly used conservation seed mix. Straw mulch was added to help keep the seed in place and hold moisture in the soil. As I mentioned earlier, tied concrete block mats are a new material for NRCS to use for grade stabilization structures in Illinois and for contractors doing conservation work. Key to the successful installation of this practice was good site preparation, making sure the practice was laid out according to the design, and making sure final grading was at the right elevations and grades before installing the mat. Continuous elevation and grade checks, along with good communication between the engineer and the contractor, helped this installation go smoothly. Now that the practice is installed, the landowner will want to stop and have a look at the practice periodically or after heavy rainfall events, so any issues may be addressed quickly. This practice should be here for many years to come, helping prevent erosion and improve downstream water quality. Contact your local NRCS or SWCD to find out more information about this practice and learn about other ways to address resource concerns you may have on your farm.